the controller a way to operate the drone before the drone's actually on. Anyone want to hold this and they'll be the first one to fly? Cameron? All right, and then if you guys want to come take a look at this, it's pretty straightforward, but there's 4 props. 2 of them are with black tips, 2 of them are with silver tips. They also are labeled with the size of the prop. In this case, it says 8045. Anyone want to guess what the 8045 stands for? No bad guesses. All right, and how do you think that translates? So what's the 80 and what's the 45? I'll give you a hint that it's broken up like that. Percentage and width? So yeah, 8.0 is actually the length of the prop. So 8 is an 8-inch prop, and then 4.5 is the pitch of the prop. So how much like the prop is like rotated, which basically is a part of like how much lift it can generate. So the more pitch, the more that you can lift, but the less flight time is typically what the trade-off is. And then there's also little icons that show you a lock and unlock icon. So you'll just have to, actually with the Developer Mini, the motors come with a threaded mount on them. So you can only put the prop on one way unless you like really force it and you like strip the threads on the props. But they're also labeled where we have caps or nuts that you could put on them that are marked in the same colors as the tops of the props. But you could also see the black tip props go on the motors with a divot on them, and then the silver tip props go on the motors without the divot on them. And so the silver props will go front right, rear left, and then black tip props front left, rear right. Go on, just like that.
I'll ask obvious questions.
Yeah.
How come the props don't spin off and the motors start?
Does anyone have a guess for why the props don't spin off? So, but what's the locking mechanism in this case? If you see that I'm just like spinning them on, how come they don't just spin off? So, yeah, the props will spin in the opposite direction that those motors are set up to spin. Now that's if the motors are set up correctly, where if we're doing like a maiden flight and someone overlooked the motor testing like on a bench, you'll have the motor spin in the same way as the prop, and then the prop will fly off if you're lucky. Or other times, you know, the prop will stay on just long enough to take off and then fly off and then, you know, have it tip over or crash. The nice thing about these self-tightening props that lock into place just spinning them on, they're more prone to just spin off if they're not on correctly. Where if you have props that you have to like actually screw into place that are like folding props, you know, it's more likely going to result in a crash or tip over upon takeoff. So this is a little bit more forgiving to work with as a development platform, but again, there are still some limitations with it, as there are any platform. But in any case, now that I have the props on, I'm just gonna go ahead and plug in the battery. It's just a fairly standard connector. It can only be plugged in one way. And I'm actually going to rotate it. So this antenna on the rear is, like I just stated, on the rear. This GPS dome is facing forward. So when we take off, the direction is facing away from us. All right, so we have the controller on. Let me see. I don't think I heard anything. No telemetry found just yet. I'm gonna restart the controller, even though you really shouldn't. I'm a risk taker, I guess.
Welcome to HTX. Throttle warning. Switch warning. Yahoo telemetry ready. Altitude hold flight.
There we go.
GPS 3D fix lock.
So we get all the telemetry information down in this little screen. And if you guys are familiar with like flying DJI, it's like, what the heck is this? You know, that's not enough to like be helpful in any degree. So we have this app called Q Ground Control. I say we have this app. It's available on Android, Windows, you know, all the different platforms pretty much. Doesn't really work well on iOS devices, and you can't actually like get it through the App Store on iOS devices. There is a way to get it, but again, kind of has limited functionality. It's pretty much the Linux of drone control software. I think I mentioned this last time I came by, but now we'll actually get a chance to use it. And we don't even have to use it at all, but this is basically a way to get all of the information that's already being reported back to that controller, just in a more visual format. So you can also do like automated missions using this software. So we could like set a waypoint mission around the parking lot here if we wanted to. And so like while Cameron's flying, you know, I could basically just take over the Develop Air Mini in flight and just say, hey, you know, I'm done with your manual flight, and I could just upload a mission to it while it's in flight using this software. Similar to how these buttons are set up, to where I just press 2, the controller said it's in loiter flight mode. So this puts it in a flight mode kind of like DJI's drones, where if you take off and just like let go of the sticks, it's just going to hover there in place. Again, should everything work correctly, you know, there's no GPS interference or anything like that. You know, it's basically just the easiest way to operate Develop Air. Now, operating inside, we would use this altitude hold flight mode because GPS isn't really reliable indoors. So Develop Air would still, or in this case Develop Air Mini, would still hold its altitude using by and large the barometer on board. So it's not using GPS to keep the altitude, but it's going to be more prone to like outdoors drifting in the wind, or if you're indoors, if you like start going in one direction, unless you kind of correct the movement, it's going to continue drifting in that direction. So enough of me talking about this software. To actually fly this drone, very similar to DJI drones, where this is the layout for a throttle going up and down on the left stick, and then you can rotate as well. Now, unfortunately, these controllers aren't quite as refined as like the DJI drones, where you could see like it doesn't really spring back to the center quite ideally. So you may notice that even when you think you've let go, that Develop Air Mini is coming down a little bit, or it's like going up a little bit, and you might just have to, you know, manually center that throttle stick a little bit. Now, the longer term is you never have to use a controller like this, but for the time being, here we are. So, and then this is all your like forward, back, and then left, right movement. So I think that's fairly understandable. Of course, you can ask questions along the way. To actually kick on the motors, you just hold that down and to the right, and it'll say motors armed. And then once it's kicked on, then you just come back over and you can gently throttle up. Or once you've landed, you just come down and then disarm down and to the left. So let's go ahead and arm up the motors, and we'll...
You do both of them like that?
It's actually just that one left stick. Yep.
Motors armed.
And then just nice and easy up on the throttle. Oh my gosh, we make drones that fly, people. Not enough of them, you know, to bring you for today, but... And so now if I wanted to mess with Cameron, I could like press the land flight mode button, and now Develop Air Mini is just going to land. And so I'm going to put it back into loiter flight mode, and now Cameron has control again.
Pretty quiet.
It's the most quiet, Yeah, no, Develop Air Mini, I mean, still has, as you know, some refinement to get it, you know, where we can build dozens, hundreds, thousands of them this way. But when they're working properly, they are the greatest platform. I don't have issues, people. All right, Cameron, I think you get the idea. Do you want to hand it off to someone else? I know fairly basic. You guys have all like flown drones and whatever, but hopefully this gives you guys a little bit better of an understanding how to fly a drone like this to where you want to get in the development side, the engineering side. Even again, if you weren't there at the last meeting that I was down here for, you know, there's a huge demand for even just technicians around here, DJI drones or otherwise. If you learn how to solder, repair these, do these sort of test flights, there's no shortage of job opportunities. One of the guys that is still working with us just on a volunteer basis because, you know, we can't afford to hire him full time. He's working at a company here in the metro Atlanta area, graduated from high school. We paid for his drone certificate, his Part 107, and then he got the experience working as a technician for us, landed an $80,000 a year plus job starting out, got like a bonus, you know, to like a personal like slush fund as well. I mean, great benefits, and there's just going to be more and more opportunities like that, especially the earlier you get into it. And now, if you actually bring it closer to us, I'll point out some of the lights, even though, you know, we're in the daylight, they're not really necessary. Beyond looking at that screen, which is hard to see anything of real value down there, just being a small little black and white screen, if we were to look at my phone screen, we could see the battery percentage is at 96%. That's not actually 100% accurate. We didn't start with a fully charged battery. But if you bring it a little bit closer to us, and then if you can rotate it 180 degrees, so you can see the red and green lights on the front, that's to show like the orientation or position. Same with the two white lights on the rear. But if you actually see these lights, it's hard to see them because they're currently red. There's actually red lights up on the top side of the fuselage, like right above and in front of the boom arms on the rear. And that's the battery status light. So you can actually see when those turn from red to flashing red, that the battery level is low, almost at like a critical state, and it will prompt a landing by itself. So just another sort of creature comfort, if you will. So if you're not looking down at the screen, but you're looking at your drone, you can see the battery level, at least roughly speaking. All right, and then for you guys, if you're interested, so we'll just do a short little flight plan because there are quite, well, I don't know. We'll see. It's hard to tell without the parking lot being actually back here, but let's go ahead and we'll set the initial waypoint altitude to 100 feet. And then I'm going to set a waypoint here also at 100 feet, and we'll just show that we could have it fly automated. So I'm going to hit upload. The controller just said flight plan received. We could actually set up like a switch or button or whatever to start the mission directly from that controller. But here we are. I just started the mission, and now Develop Air Mini is flying autonomously. It's rising up to 100 feet. We could track all of that here on the screen, or again on that screen as well. But I am actually just going to have it return to the launch location as it's going to waypoint 2. I just telling it confirm, and it just says it's coming home. So, and by it, the controller says the Develop Air Mini is coming home. And from here, we could let Develop Air Mini do the rest, just land itself. But at any point, we could also take over manually if we so chose. And with a fully charged battery, if you completely exhaust it, you're not like trying to exhaust it as fast as you can, but doing, you know, fairly normal flights with it, you can get just above a 30-minute flight time. Realistically though, I wouldn't recommend pushing it much beyond 25 minutes. especially if you're attaching any payloads or doing very like fast, energy consuming flying. And then you'll probably get like closer to 20 minutes. Let's see, is it gonna clear that ledge or is it gonna be, I think we're good. All right. A little grass cutting. And the prop. It's just saving us some work, one less prop to take off at the end, so. All right, you guys have any questions about what you saw, what you experienced? Super exciting. A lot of the fun, with these comes from actually doing a mission that provides value, right? Not just flying, but of course you need to have a platform that is capable of stable flight before you can attach any cargo or sprayers or cameras or any sort of other peripherals. But unless there's anything else that you guys want to do while we're out here, at least for the time being, we'll go back into the classroom and then show you a little bit of the setup and configuration process for that larger developer that we have in there. Apart, but again, all of that is kind of predicated on just having a stable base platform that you can build all these other ideas on top of or under of. But in any case, so this GPS we are going to use in this build because this is like an $80 GPS that is supposed to perform as well as like those $300 and almost $400 GPSs. However, we have just not been able to figure out the proper configuration for this GPS now on a couple of different models. And so the standard GPS unit that we use for these larger developer models is about a $40 GPS unit. Fairly good, but much more prone to interference, right? And then you're more likely to have to do like a compass calibration if you go fly in a new area, especially surrounded by concrete or structures, buildings, etc. And then so kind of a nice in-between for what we have right now is the GPS that we use in the Developer Mini. It's actually better than the standard Developer GPS, and so you'll get connection to more satellites, but the connection isn't necessarily as good to stay locked onto those satellites as it is with these like RTK GPSs. But nonetheless, we have this one configured right now with this developer using the GPS 2 port. And we were able to get this GPS like configured and like ready to fly properly. But then it seems like we might have not had our radios configured in the correct way yesterday. So before we actually take on the radio configuration, I'm going to unplug this GPS unit and replace it with the standard unit and see if we could actually achieve flight with the standard GPS, as we have many times before, but unfortunately sometimes the reality is we go to put one of these together and all 4 of the motors should spin up and only 2 of the 4 motors are spinning up. And that was actually the case with this developer, where for sure I thought it was going to be 2 of these ESCs. So these are what are called electronic speed controllers, and each of the motors are plugged into one of these, and there's 3 connections, 3 bullet connectors coming from the motor that are plugged into the female bullet connectors on the ESC. You could switch the direction that the motor spins in by just taking any 2 of these 3 connections and swapping them. So there's no like ground, power, and data. They all just send power, and to switch the direction of that power, you just swap any 2 of those 3. And so I thought for sure that there was something wrong where 2 of the 4 ESCs weren't working. So in the software that I'm about to pull up again, Q ground control that we're using to fly the Developer Mini outside, you could say, hey, I want to spin up motor A or motor 1 and see which direction it's spinning, make sure it actually spins up properly, go through all 4 motors like that, and only the first 2 motors were spinning. And it turns out the flight controller, like the main brain of the drone, was actually the problem. I had completely like wired up a whole new ESC assembly, connected that to the flight controller, went back into our drone control software, and same problem. Only 2 of the 4 motors were spinning up. And I was like, I really doubt that the flight controller would be a problem, especially because I reset it to like the defaults as you would get it from the factory, updated the firmware to the newest version, and lo and behold, what seemingly a new component just is not working properly. Now, it wasn't like I took it out of the box, but it's like, there's a lot of gremlins, if you will, or a lot of inconsistencies in the engineering, production, and development process that, you would like to think you build one, you can build, 10 exactly the same way, but doesn't always prove to be the case. So I would say enough of me yapping, but now there's just going to be more of me yapping with visuals to go along with it, digital visuals. All right, so we could connect via a radio connection, similar to how we were doing so with the Developer Mini outside. Now, I didn't cover this, but you can use this software via a USB connection. So directly built into the flight controller, there's a USB-C connector on the side, so I could plug my computer directly into this and be able to connect to it. But what we did to make it a little bit easier, especially when you're out in the field, if you don't want to use your radio connection, you could just plug in to the fuselage there. We just basically, we don't make these cables. We buy them from China and then have like an extension going from the flight controller to the exterior of the fuselage. Let me see if I can, oh, there it is. I was using it as a charging cable. You can use a USB-C to USB-C connector, but I find, again, even though USB-C is supposed to work both ways, sometimes like the manufacturers of these sort of components or the manufacturers of these sort of cables don't actually follow the USB-C standard in the way that it's supposed to. So we found in some times where you're using like a USB-C cable from a USB-C port in a computer to the flight controller, or especially when using the extension cables, you'll actually have to like flip over one end of the USB-C cable to actually get the data communication to work properly. So, technology, great when it works and it's developed correctly. And now typically Q ground control would like talk and give you a lot of sass. Depending on the version, it's a male or female voice. I don't know if there's a way to change that, but I've muted it. So if you download Q ground control ever and you start hearing it like screaming a bunch of like messages at you, you've been warned. So by default, when you open up Q ground control, it will, and you have a drone connected, it'll pop up that vehicle configuration screen, which is also accessible via the top left-hand corner. And this is where we can get to that motor testing screen I was mentioning. And you can now adjust the throttle on the motors. So for instance, if I want to spin up motor A, I would need to then adjust the throttle value I want to send to it. And I actually also need to have the battery plugged in. So a USB-C connection is only 5 volts, and so 5 volts is not enough to spin up these motors. So let me go ahead and plug in the battery. And now I'm going to press A, and theoretically that should spin up the motors to 7%. Now I press A, nothing happens. Press B, nothing happens. C, nothing happens. D, nothing happens. Any guesses why that may be? this like was a killer for us for a while. It's like we've set up drones like this before, we've done motor testing, like why are they not spinning up?
Is there an issue? My thought is like it's a communication issue between the laptop and that. Where would those be in the drone?
So it is a communication issue of sorts, but not exactly in the way you described. So basically with each combination of motors and electronic speed controllers, there's going to be a different value for what like the minimum speed that the motors can spin up. So we, for the life of us, and this UI has changed to where now you can like set the throttle value to a specific percentage. It used to just be like a little slider bar, a vertical slider bar. And so you would like click up on the slider bar or drag the little ball up on the slider bar to spin up the motor. And so you would be like roughly halfway up this slider bar, but you don't know if you're spinning up the motor to 40% or 55%, 51%, whatever. And so we actually found out that with these motors, it's somewhere about 17% is the minimum throttle that you have to send it. So now I'm at 20%, I hit A, and oh my God, we got a motor spinning. So what I did there, we used to just use tape to be able to like make a flag essentially on top of the motor to see which direction the motor was spinning. But once you get a little bit more comfortable with it, or you just start off more comfortable than, you know, some people, definitely not myself, you could just run your finger along the side. I'm gonna say you're not gonna hurt yourself, but you know, you could be you could be the exception. And so just going through A, B, C, and D. And so the real key here is that all the motors are spinning inward. So this front right motor is spinning in towards the center. And that might be confusing because it's like, isn't it this also the center, technically speaking? But if you think about it from like a front to back perspective, all of the motors should be spinning inwards, right? So again, counterclockwise, clockwise, counterclockwise, clockwise. So I think all the motors are set up correctly here still. But we don't have a GPS, and so I don't know if we would get a satellite connection here in this room. We'll find out here in a little bit, but typically you would see your satellite connection established there. So let's go ahead and put on this new top cover with the standard GPS unit, and since we only have the one radio across all these different top covers, it's just taking the antenna off, pretty straightforward. And then there's some brass hardware, just a hex nut, a split nut, and then a washer in that order. All right, and then just back on, the washer goes back on first, and then there's like little divots on the washer. Those face up. It'll work really either way, but just to do it the quote-unquote correct way. After the washer goes on, the split nut goes on, and then the hex nut goes on. You need 2 of these nuts for every top cover. All that matters is I find myself funny, right? No one else. No. All right. As simple as that. And so this time the radio is going right back into the TLEM1 connector. And then instead of using the GPS 2 connector that we're using for that Develop Air Mini GPS, we're using the GPS 1 connector. And you can see it's already powered on. I'm gonna sneak that radio back in there and make some room for that GPS cable. Now, what's interesting about the motor direction and spinning up I was sharing, so if we were to use these exact same motors, but with this electronic speed controller, so there's just this one board that replaces all 4 of those larger electronic speed controllers that I was showing with the 3 bullet connectors coming from each one. So you can see there's, 12 bullet connectors on here. So one motor goes to these 3, another motor goes to these 3, another motor goes to these 3, another motor goes to these 3. And then using this wire from the ESC to that flight controller, you can actually spin up these motors at like 3% or 4% throttle instead of 17% throttle. So in flight, doesn't really have too much of an effect, probably not that you're ever going to notice, but you just do have more granular control over the motors using something like this, and more of that's due to the actual protocol, like the way that the information is being sent to the motors and back versus the actual form factor of this 4-in-1 ESC. A lot of that's technical jargon, but I don't know, I thought it was somewhat interesting to see that, you know, the same motors can spin up at different values depending on how you're driving them. All right, nonetheless, we have the GPS connected. What we're going to do is reboot before we go ahead and change any parameters, or at least review the parameters. So reboot, we're going to see Q ground control being open source software is very prone to crashing. All right, and now I'm going to go back to the vehicle configuration screen, select parameters, and the first thing I'm going to do is tell the GPS where I have it plugged in, because previously I had the Developer Mini GPS using this 6-pin connector to the GPS 2 port. I no longer have a GPS in that GPS 2 port, so I need to go in, and this is where it becomes a little bit more technical, that you have to do some look at documentation if you don't know like where to go in the software directly. So let's see if I have any of it pulled up still. I probably do, but I'm going to search Pixhawk 6C. That's the name of the flight controller. It says it on there. So always look for labels when you're not sure what to Google. Pixhawk 6C, and then I'm searching what are called serial ports. So each one of those ports, or most of those ports on the flight controller, while they have a label like TLEM1, TLEM2, TLEM3, they're all types of serial ports, which is basically like USB is a type of serial port. It's just a way that data is structured, essentially. So this has all the information about like what pin, what each pin does as part of each port. And then this is actually not the right page here. There's a breakdown, and I passed it. Yeah, UART mapping. So serial 0 is the USB port on the side, and then serial 1 is the telemetry 1 port. That's where we have the radio plugged in. Serial 2 is a telemetry 2 port where you could have another radio plugged in. Serial 3 is UART 1, or the GPS 1 port. So we know that we want to use serial 3 to say that's where the GPS is plugged in. And then serial 4, UART 8, is the GPS 2 port. We now want to disable that port to say, hey, we don't have anything plugged in there anymore. Serial 3. So basically in this parameters list, I just went in and searched serial 3, and then I'm going to set serial 3 protocol to, imagine this, GPS. It is that simple, believe it or not. You just need to know where to go. So it did just give me a message to reboot, but before I do that, I am going to select serial 4, and where that says GPS, scroll up and select none. And now I'm just going to select reboot. We're going to see Q ground control crash on us again. And we'll reopen it. All right, we're saying we're getting no GPS lock for a vehicle, but you can see now we at least get a 0 for how many satellites it's connected to, and a 100 for, this is what's called horizontal drift. It's HDOP. I forget what the OP stands for off the top of my head, but it's basically how many meters your drone is going to be able to like drift when it's using GPS for positioning. So you typically need about 10 satellites and a score of like 1.2 or lower. So basically, if you're connected to 10 satellites and that number goes from 100 to 1.2, your drone can deviate 1.2 meters from where it's supposed to be holding its position. And so again, that's the benefit of more satellites, and then higher grade GPS units. You can just control that position with a lot more granularity. So before we do anything else, let's go ahead and see if we're actually going to get a connection to satellites outside. I don't think we'll get to flying it, at least by the end of this class period, but if we are getting a connection to satellites out there, then the next step is going to be to set up the proper parameters for the radio in there. So let's go ahead and we'll take this out with us. And if I can get someone to kind of walk in tandem with me, grabbing this develop air with the battery, one hand on each, please and thank you. Perfect, thank you.
Welcome.
All right, and then even though I probably don't need to, I'm going to reboot and just basically reset the home position. And now when setting up a new GPS, it can sometimes take, 3 to 5 minutes, maybe sometimes even a little bit longer to set it up for the first time. And then it's typically locking onto satellites within, less than a minute. Oftentimes, by the time like Q ground control or your ground control software, like the iVue RC app, which is our software, loads up, you're already, pretty much ready to fly, connected to all the satellites you need. So still waiting for the GPS lock, still connected to 0 satellites, but we'll give it a few moments here.
You get pretty good. You get a few satellites inside typically, but
Yeah, we got like 25 satellites with the Develop Air Mini, so we should be picking them up. But it can take a... Let's see. Here we go, and look at that. We have 4 satellites. And so the 100 number just dropped down to 5.5. And so we give it a, 5 point, and now it's actually 5.6 meters. And so the arrow that's showing Develop Air's position on the map just like totally jumped to like way away from where we're at, just jumped back. And yeah, here we are. We're at 9 satellites with a 1.0 HDOP, or now 11 satellites with a 0.9. So we should be just about ready to fly. I think all that's stopping us from flying, one, obviously the props being on it, and then the radio configuration. So basically it's just saying we need a controller to be able to arm it right now, but you could bypass all that with parameters. So I think we could take this back in, and we can go ahead and do that. Again, may not be able to get right back out here and fly by the time the class ends, but one step closer into knowing how to build and fly a developer of your own. Or now actually a few steps closer. All right, so I am now pulling up a cheat sheet that I have, and we're not going to copy it exactly because this is actually the cheat sheet or parameters list that we have for our base model developer, which looks a lot like this, but it has smaller motors, so it can basically carry a 3-pound payload instead of a 7-pound payload. And then I don't know if we covered this the last time I was here or if you guys already know this, but do you guys like understand the cell count of batteries? Is that something you've ever heard of, like how the voltage of batteries? Let me see if they're labeled here on these batteries. I can read 8.5 volts. So these are just 2-cell batteries. So basically there is like, if I had to guess, if we were to crack this open, there's like 2 almost like AA style like battery cells that are in here, like this casing is surrounded, versus, and they're bigger than AA's, but typically battery packs like this are made with like 18650 cells, or they look very similar to like these types of batteries, right? And so each of these batteries is like 3.5 to like 4.2 volts, depending on the charge level. But then you can wire those up in, I need to think this through, 4S. So if you wire them up in series, you'll get a higher voltage. And then if you wire them up in parallel, you get more capacity, right? So this is what's called a 6S. And then I think it's a 2P pack. So it's basically 2 packs of 6 batteries, right? Just kind of sandwiched together. And this is a higher voltage than like the Developer Mini, where it's 4 batteries that are sandwiched together. So it's a 4S 1P. So basically, the larger developer model just uses a 4S 2P pack that gives you like twice the capacity, but doesn't allow you to like spin up the motors as fast to be able to carry a heavier payload. So you're essentially just getting more voltage with this 6-cell battery, and yeah, it's just not the best way of explaining it, but I think you guys kind of get the gist. But any case, we already did a lot of this setup previously, but like I said, we need to configure the radio properly, and then all of the fail safes as well. So if you were to like lose connection to developer while it's in flight, it will go back to the landing location, or return to home, or return to launch, whatever DJI calls it. But let's go ahead and reconnect here via USB. All right, I'm going to scroll down all the way to the MLRS, or the radio specific parameters. So I already talked about the serial ports, and so similarly we have some options that we want to configure for serial port 1 where the radio is plugged in. And we'll actually start from the bottom up. What we need to do is go to serial 1 options and set that to 4096. Serial 1. Oops, that stays at matlink 2. And I don't know exactly all of the technical specifics of what this does, but it allows the information to get from the drone to a controller like this or a computer with a radio plugged into it in a way that is properly formatted, for lack of a better way to explain it. So again, it gave me a message to reboot, but before I do that, I'm going to set all these SR1 parameters, and again, that's just basically configuring the radio to stream back different pieces of information in a format that our software or the open source software is going to accept. Okay, well, yeah, thank you for your time. Sorry I couldn't get this one up and flying with you, but yeah, of course. Yeah, yeah. And that's it, folks. I droned on and bored everyone to death. See you guys. Have a great holiday. Happy Thanksgiving.